Can start? आप मुझे बता देना. Good morning to all of you, and first of all, like to thank National Institute of Disaster Management, Ministry of Home Affairs, Government of India for providing ISRO the opportunity to talk on the landslide hazard mitigation, mainly related to environmental and emerging issues. What we are discussing in this international conference. Now, I would like to inform you that the landslide hazard assessment, which started in this country almost 3 decades ago, and principally it was started by the engineering geologist and some geologists and geographers. At that time, it was a research subject, and it was more like a supply driven approach, means those who knew about the slope failure phenomenon, and they were doing the studies and uprising, publishing papers and uprising society that the possible consequences because of the landslides. Subsequently, as we moved on, since late 80s to 90s, 2000 and now, this landslide has become a growing issue, growing concern in all the hill states of the country. Roughly, there are around 22 states where the landslides have been reported. And therefore, the demand for the landslide studies have grown tremendously. So now it has grown so much that it almost, it has the demand is much more than what the geoscientists in this country can provide, the information and the critical solutions what society is looking for. And that is mainly it has happened due to the impact of the climate change, which is now being felt much more than before. And the developmental challenges and developmental priorities what have been taken up by the recent government and subsequent recent government and by the government agencies as well as the private sector. So this development and the climate change, they have a close link with the landslides in the hill area, and that's the reason actually the demand has increased to know more about the landslides and find the solutions which are cost effective and meaningful. Now, we know the problem and we know the issues, but the most fundamental aspect is when you look at a global map of landslides, why India has emerged, or the Himalaya mountains have emerged at the hotspot of landslide. That is mainly, this has to be understood from 3 aspects. One is the climate, tectonics and the erosion, which is very, very unique to the Himalayan terrain. The intricate relationship between the climate, tectonics and erosion, this needs to be understood. And in subsequent slide, I will just try to show how complicated it can be. And essentially, we need to understand the mechanism of the landslides. And the second important aspect is that the landslides and development, which is basically a society interaction with the slopes, vis-a-vis the climate change, so which indicates the extreme rain and rain in place of snow. Earlier we used to have rainfall, now we have many places we used to have snowfall, now the snow is replaced by rain. So the slopes are no more stable under the different, the mechanism of the precipitation. So this is so interwoven that the development, so one is the natural cause of the landslides, slope stability issues. Then there are developmental issues for, the development happens along the hill slopes. Then there are society interaction for cultivation and settlement and so on, and climate change impact. So all things are interwoven. So what is required is a more holistic earth system science view. Now that is currently lacking, mainly due to the fragmented approach which is being followed. And it is initially, sometimes it happens that we try to reach a quick solution. To find a quick solution, we try to ignore the complete picture because that takes time. And but that is one of the reasons that some of these approaches what has been followed for the landslide understanding that requires certain point of time we feel that it may not be sufficient. So I encourage these experts and the stakeholders to give some attention to the earth system science. The earth system, how does the earth work in this part of the globe, particularly the Himalayan sector across the 2500 kilometer length and 300 to 400 kilometer width. The entire zone, we need to understand how does this earth system science work. And what is important at this moment, I would like to emphasize on the people-centric, simple landslide hazard mitigation strategy. What we have deliberated so far, there are very expensive methods of landslide mitigation. There are certain methods which really may not work on the ground. So with our experience working since 1990, I would say that our first landslide study at Indian Institute of Remote Sensing started with the hydroelectric project, Parvati Valley hydroelectric project, and the Nepal highway alignment project in early 80s, what our institute was carrying out for the Nepal government and for the hydroelectric power projects, Himachal government. There we came across the landslides, and since then we have been studying. And so what we understand about last 30 years, 3 decades or 4 decades of journey, what you understand, that what is required is a very, very simple people-centric approach which is sustainable. Currently the methods, techniques, what appears to me personally, that very, very extremely costly, and expertise what is required often not available, and that's one of the reasons that why we don't have a large scale deployment of mitigation measures. To make you understand in a very simplistic manner, why can't we use the UAVs, the unmanned aerial vehicles, or what popularly we call drone, and satellite images of very high resolution. We have seen yesterday India has launched a new satellite which will provide a sub-meter resolution satellite image. To monitor, such satellite images can be used to monitor landslides in our neighborhood. And these people can be trained, students can be trained, and stakeholders can see themselves that how the UAV data can be acquired. At a fraction of a cost, satellite images can be analyzed to map, monitor the landslides in closer to the villages. And the technology is developed, we have developed very good technology for the high resolution deformation monitoring using satellite based observation as well as terrestrial or land based observation and subsurface probing. Landslide essentially starts due to the earthquake or due to the, the pore water pressure rising because of precipitation, and a lot depends on the subsurface features, geology of the terrain and geotechnical properties. So it comes down to not only satellite based observation but some kind of a subsurface probing. And this subsurface probing is successfully done by Indian Institute of Remote Sensing with geophysical techniques. But I would say that the satellite based observation and the subsurface probing, the technology exists today. We are in a much better condition today than few years back to provide solutions. Not only that, to study all aspects of landslides, do the mitigation measure, we have whole suite of technological solutions which are proven elsewhere for other fields, but there are very few takers to deploy them for the landslides. That's a matter of concern, and this concern I am sharing and just telling that the technology exists today and we can reduce the impact to a significant level. Now, what is that one thing we should do to minimize the cost? What is the immediate thing is the developing an early warning system and low cost preventive measures to contain the landslides. I am not using the word control. Control means it's a much larger term, and to have a control on a natural phenomena, and that natural phenomena is happening because partly due to natural causes and partly due to the human interference. So I would not say to control the landslide, I would use a milder term to contain the landslide. And that can be the curative cost of a landslide could be prohibitive. to give us some idea that one landslide may take 20 to 30 crores, maybe 50 crores of Indian rupees, which is prohibitive. And if you look at the landslide, number of landslides in the mountainous region, one example is that one earthquake can happen of 7 magnitude or 8 magnitude, and it can cause something like 3,000 landslides. We have seen it in 2005 Kashmir earthquake, 2008 China earthquake, though those are our 7.8 magnitude events causing more than 3,000, 2,000 to 3,000 landslides, maybe more. So can we spend 20 crore to 30 crore rupees at each landslide? Developing a technology, we can develop a technology, but question is that, do you have that much of money, the resources to do it across 3,000 landslides? So I would say much cost effective. So curative cost, the so-called the engineering methods could be prohibitive. So containment cost, that includes about the very simple techniques, low cost techniques, includes the the bioengineering methods, water management on the top of the slope, and some surfacial remedial measures at a fraction of a cost, and that can be less time consuming, and it can be very effective. So the idea is that I want to provoke the traditional thinkers of the landslides. Can we achieve a zero casualty status due to landslides? Is it a tall order claim? Or as you have almost done so in case of the cyclone, particularly the Philin cyclone and the Fani cyclone, it came down to double digit in 2015 and 2019. Whereas the similar level of cyclone or little higher magnitude cyclone in 1999 in Odisha, the death toll was more than 10,000. So 10,000 to double digit death toll, that shows that almost we are reaching towards a zero casualty status in case of the cyclone, essentially due to the deployment of technology, satellite technology, weather forecast, and very strong administrative network and action on the ground by the state government. So the Odisha state government has demonstrated that how the effective measures can be taken to implement to reduce the loss of life, and they were primarily driven by two things. One is the scientific inputs on cyclone warning, which IMD has very successfully, precisely provided in case of these two cyclones, and the similar thing can be replicated elsewhere for other such events. And I draw the inspiration from that, and looking at the technological expertise what ISRO has built, or many CSIR organizations, universities have built. So looking at IITs also have contributed a lot, and they have built such technological solutions. I'm sure that we can achieve a zero casualty status or a near a zero casualty status in case of the landslides. Now I'll just briefly show you a couple of them. This is the whole philosophy of my presentation, and I'd like to explain you the intricate relationship between the tectonics, erosion, and the climate. So it's very interesting. Himalaya is rising, and there is an Indian plate is hitting the Eurasia plate. So we have a system called, whenever the one plate is hitting another plate, the plate collision happens, and the mountain building process starts taking place. So mountains are rising. The moment the mountains are rising, there is orographic rainfall is increasing, and when the orographic rainfall is happening, so mass wasting will happen, and when the mass wasting happens, the isostatic balance will change. Because of that, again mountains will rise, and when again the mountains rise, more rainfall and more erosion in the form of landslides. On top of that, we have a climate change there. So because of the climate change, we have additional rain happening, and this additional rain is causing more orographic rain. Additional rain is coming in the form of orographic rain, and because of that, again there is a higher level of rising of the Himalaya, and again because of that you have more rain and more landslides. Now this process is continuing for last say 50 million years since the ever collision took place. So you have a plate motion, then there is a erosion, and there is a climate change. So three things are integrated. That's the reason why the Himalaya have Himalaya mountains have emerged as the hotspot of landslides if you analyze the entire global data sets. So, looking at the technological solutions, just to highlight that how the geoinformatics or the remote sensing, space-based technology and similar things can help. There are a lot of things possible: mapping of active and old landslides, causative factors of the landslides, then identification of the landslide zones, hazard zonation can be done, deterministic modeling, factor of safety calculation traditionally which is done by the geotechnical experts can be done. Deformation, slope deformation can be monitored using the differential interferometry synthetic aperture radar and global navigation satellite system. We can use a terrestrial laser scanner to generate a digital elevation model, and we can also do the similar thing using a unmanned aerial vehicle which will provide you information about the deformation places. Subsurface probing by geophysical techniques using ground penetrating radar, geophysical techniques like the resistivity methods, and monitoring performance of slope stability measures, that is also possible using these techniques. You can monitor how good is your slope stability measures which has been adopted by engineering method, how good they are performing. If they are not performing, you can find it out very cost effective way using these observations. Early warning or the early detection system, that is quite possible, and many things we have done actually very regularly we have been doing, and what is possible is written, many things we have attempted and successfully we have also done. Just to draw your attention to the different landslides in the Uttarakhand region, I have taken for Himachal and Uttarakhand, and look at it. The first diagram picture actually shows due to bank erosion how the landslides taking place in the Giri river, that is in the Himachal Pradesh. The road construction, slope stability has been disturbed, and we have a lot of landslides across the slopes. Then we have a place called Lambagarh, which has experienced landslides mainly due to the climate change impact, and it started in late 90s, and still till now it is continuing, and the road diversion other plan has been taken up. And we have built dams, and dams have reservoirs, and the reservoirs fluctuate. Because of that, the ream areas are also have become susceptible to landslides, and this problem is there also in the case of the Tehri and in the Three Gorges Dam of China. Now, to demonstrate that what really can work on the early warning system, we attempted a rainfall threshold based modeling, and very interesting, that during the Kedarnath disaster, huge landslides occurred apart from the flash flood. And if you look at this information, we have a threshold indicated by this red graph. So this red graph goes very, very fast up, and traditionally when the graph goes more than 80 or 90 values, we are normally concerned. And you can see this on 14th and 15th, even on 16th, 15th and 16th actually, already it is known the huge landslides possibly can take place, and the disaster happened on 17th actually. So 17th we had little rain, but which rain had occurred on the 14th, 15th, 16th were enough to cause these the massive landslides which blocked the Mandakini and the Saraswati, and when the Chorabari Tal actually breached on 17th of early morning, the water could not flow through those channels which are blocked by the landslide debris. This was the discovery by our team. The important point what I am trying to highlight here, the IMD had given the rainfall forecast, and we had the landslide model. If we combine these two, on 13th and 14th you can know actually this graph. So it is no more a post-mortem, what we have done a post-mortem analysis, but it shows that it is possible. You can use the similar things to know things in advance. Another one, a La landslide which happened in 2009 in Uttarakhand, and similar high rainfall has occurred on previous 3 occasions or 4 occasions. But the slope stability actually got disturbed on a particular date, and this could be monitored, modeled using some parameters from the ground, and exactly we could do the back analysis and saw the highest amount of moisture was available at that site on the day landslide occurred. So what I am trying to show is that the physical based models are possible to do And if we have the rainfall forecast in advance, for any area we can run the model and tell when is the landslide likely to happen. So the landslide early warning system, what I am talking, is the one thing we must do. Set up automated rain gauges because they are scarce in the Himalayan terrain and some of the hill areas, other hill areas like the Western Ghats and the Eastern Ghats, which have increasingly experiencing landslides due to various reasons, rainfall, extreme rainfall and developmental work. Landslide inventory and preparation of the landslide hazard zones and maps using remote sensing and GIS. This is something which we have been doing rapidly, very regularly. Deformation confirmation by DINSAR, SBAS techniques, PS-INSAR and GNSS based observation. Some of the new techniques have been proven by various agencies including ours. Deformation of the order of few centimeters can be known by differential interferometry satellite based observation. So this is something what we can do much better. After 2 years we will be launching a new satellite called the NISAR. ISRO, this is basically NASA and the ISRO mission. It's a global mission and one of the most powerful satellite which will have a tremendous interferometry capability and provide at a very, very high temporal resolution data sets. So every every area in the Himalayan terrain can be monitored in a interval less than 10 days. About its movement status can be known. And technology is there, like DINS, we have the SBAS or PS-INSAR techniques. So which softwares are available and it can be used to find out the movement beforehand. Landslide rainfall threshold relationship, intensity, duration. There are two type of things what we are looking at. Rainfall threshold relationship and the intensity duration relationship. The two relationships we are looking at with the rainfall data and the landslide data in the past can be developed and can be kept ready for every area. And using the rainfall prediction, what nowadays the IMD does quite a good job on that, and we can estimate the landslide probability for different zones. Then we can issue the early warning as and when required when the threshold goes up, and then we can also do the debris flow rockfall modeling to determine the flow path. If a debris slide, rock slide takes place, how far it will go, what will be the momentum, what will be the velocity, what will be the run out distance, all can be known, and once you know that, people can be evacuated or traffic can be stopped. So near real time and real time monitoring using DINSAR can be done to reconfirm to see the further fine tune what is our early warning what we give. That is where also we should involve the community, satellite or the UAV based observation to confirm the movement what we see from the satellite. Then finally we should evacuate or the restrict traffic, vehicular traffic, and then we should have mechanism to take off the warning so that there is a minimum blockade of the traffic or the loss to the people. So landslides towards a zero casualty status, this is what our dream, I feel it can be achieved. So remote sensing based landslide inventory, deformation monitoring, all what I am telling, we have the backup capacity building program, technological demonstration program, and we can teach people, we can train people, and we can help in executing projects. That is what we have partly done for the Uttarakhand government, and most likely we will be doing the similar thing for the Odisha government with IIT Bombay. And many international institutes are coming forward, our organizations are coming forward for technological support, funding support to take up the studies. And what appears to be today is the fragmental way we are approaching, small case studies in different sectors, but holistic manner. The time has come, technology has matured, and the demand has increased, so we should be able to deliver what is required on the ground. Historical satellite image based analysis for vulnerable slopes and preparation of the hazard zones and maps easily can be done. Automated weather stations should be there for the monitoring of the vulnerable slopes, and rainfall threshold can be calculated, which is not a very simple rainfall threshold. So the cumulative rainfall, the most immediate past rainfall, so using different parameters of rainfall, the relationship can be known. Then early detection It's possible using synthetic aperture radar, optical remote sensing, UAV, GNSS, or crowdsourcing. People are involved, they see back on the back end some kind of crack developing, some kind of subsidence taking place. They can inform through mobile app, and the central office like ours, we can always see those data and get the information right from the ground. So combination of people-centric and space-borne information can flow to the database to enrich us and give us early warning. We need to have a bottom-up approach. That debris flow rockfall simulation should be done for all high-risk areas, and we should demonstrate the how the evacuation to take place in case of there is a landslide. So suppose there is a village and there is a steep slope and there is a possibility of landslide, we should run a model, simulation model, and show people that how the rock is going to flow or fall, or debris is going to flow through their village, and accordingly they can be alerted. And we can do the drilling. Drill and evacuation, drill unless we do, actually we won't be successful to do the evacuation actually when it is required. Drone, total laser scanner, GNSS based slope monitoring should be mandatory for all major ongoing projects. It needs policy guideline, and once it is there, the companies or the projects will undertake that. Mainstreaming disaster risk reduction developmental planning, this is what Prime Minister has articulated, one of the most important thing. So using building, road, hydroelectric project related construction as a means of strengthening slopes. So catchment and dam side monitoring for the slope deformation should be the responsibility of the agencies dealing with that, but we need the policy guidelines. Once policy guidelines are there, these companies and the agencies would take up those kind of work. There is a paradigm change in the policy framework. Construction at any site having slope more than 20 degree should have slope stabilization measures with financial commitment. Say 10%, 20% of this total project cost should be dedicated towards the slope management, that is essential for the slope protection. State should provide the policy guidelines, this is important, and government should develop some kind of set up a knowledge cell depending on the problem, acuteness of the problem. States where the problem is not so much, they can just have a knowledge cell, and where little bit more problematic areas, they can have an advisory body. At some states where landslides are critical, geoparadising the investment in the development, they can have a landslide authority. It's a very flexible model. You can have a knowledge cell, you can have an advisory body, or you can have a landslide authority. State like Sikkim and Uttarakhand should look at having a landslide authority with some legal powers. At the end, we need a people-centric, low-cost solution that can be educative to people. What is landslides? How to reduce its impact? How to contain the landslides? Basically, how to live with landslides. We have to teach people how to live with landslides, and which is sustainable in long term. Currently, this is sustainability in long term is a key word, and if you bring in very, very complex technology with a heavy cost, it's unlikely to be sustainable, because we have huge area, and people would not like to invest too much, and they would like to always look for the state support, and state support is almost, we may not get always for all the areas. So we have to develop some people-centric low-cost solutions, and which can educate people and they can implement, and which will have a long-term sustainable effort in landslide hazard mitigation. With this few things, once again I reiterate that the technology exists today for satellite-based observation, ground-based observation, and subsurface observation. The three observations are to be combined together to provide a solution which is low cost and sustainable in future.